what's the minimum number of degrees I can rotate this so I get this same exact pentagon where it is. It doesn't move. It's not tilted a little bit. It's the same exact pentagon. And the way we do this is, hey, we know if I go all the way around, that's 360 degrees. That's always an answer, but I can tell you it's never going to be a choice. All right, it's never going to be an actual answer that I need to circle. All right, is it a choice here? Sure, it's choice 4, but I'm looking for the minimum number, and there's a smaller amount than 360. But I start at 360 because I know if I go all the way around, I'm going to get that same pentagon back. I take 360 and I divide it by the number of turns it's going to take me to go all the way around. And how do I figure out the number of turns? Depends on the figure. This is a pentagon, and it's got 1, 2, 3, 4, 5 vertices. Meaning, if you turn it 5 times for each vertice, you're going to go back to the original pentagon. All right, so I got to turn it 5 times. So I take that 360, divide by 5. And as you punch it on your calculator, you'll notice the minimum number I can go is 72. So that, hey, look, that tells me vertice to vertice is 72. It might not be the only one, right? I can go another 72, another 72, another 72. But for this answer, it's looking for the minimum, which is 72. And yes, you do need to know how many sides a pentagon has. That's not on any reference sheet. That's what you need to know. Going over to 9 now, how about a decagon? Again, it's come up. All right, this is an old Regents question. You got to know how many sides are in a decagon. All good? So you take your 360, which we know is an answer, but it will never be an actual answer. And I divide that by the number of turns, which matches the number of sides. Decagon, anybody? Decagon? 10 sides. And again, if you don't know that and you're on your own or studying with a group of friends, you look in your cold hard facts packet. They're all listed right there. 10 sides. So I divide by 10, and you'll notice that we do get 36. That's not a choice, is it? All right, so go another vertice by adding another 36. You could also go 72 and get the same decagon back. Still not a choice. Keep adding 36 to go from every vertice. And I'll let you do that, and I'll figure out who's got it. Keep adding 36. Keep adding 36. You'll get that same decagon back. Jesse, when you keep adding, which one is up here, an actual choice? 252. Yep, I can do it 252 degrees. One question. It's going to be nice and easy. If again, we got to know how many sides in all these figures. All right, and that is listed in your cold hard fact sheet. All right, questions on rotating polygons. Anything, we did 2 monster topics on Friday with quadrilaterals and SOHCAHTOA. Is there any specific questions that you want to go over before I move on? And again, you try them out fine. If not, I'm fine with that too. You guys heard my spiel, my rant, the first day of review. All right, I just don't want any complaining, tears, excuses. All right, when we take the actual exam and it doesn't go well. We're all good? Okay, today is going to be 2 other monster topics. We're going to start with similar triangles. So let's start it off here with number 1. We're told that ES parallel to AT. Which one of these is true? First thing we got to cover. Because, hey, in 2 weeks from tomorrow, it's not going to say similar triangles at the top of the problem to let you know. So first thing I got to review, how do I know this is a similar triangles problem? First, because they told me those lines were parallel, anybody know what type of angles those are? I just marked congruent. Those are corresponding, so they're congruent. So are those two. Notice the two triangles have 2 pairs of congruent angles. This is, everyone remember, that's angle, which means the triangles are similar. So that's how I know it's a similar triangle. Something to do with similar triangles. right? Because I won't have the big word similar triangles up there on the Regents exam for you. So now that you know it's similar triangles, a lot of things are in play. First thing I want to review with you is what we have called the side splitter theorem. All right, side splitter theorem. If a line is parallel to a side in a triangle, which is what I have, don't I? I have ES parallel to side of a triangle AT. It creates a proportion. It creates a proportion with the other two sides of the triangle, with the other two sides. So first, everyone see I have ES parallel to a third side of the triangle. It splits the other two sides in proportion. CE over, and this is the only instance where you can use a partial side. Only instance. CE over AE is the same ratio as, go on the other side and do the same exact thing. CS over ST. It's the only time. You can't just do it whenever you want. They have to be parallel. You have to have a parallel line in there to do that. And I believe that's a choice up there, right? CS over choice 3. All right, hey, I'm not done with this problem, though. I want to show you another version using whole sides only. You can only use the partial sides if the darn line's parallel. Okay? If not, I got to do full sides. So now I'm going to start calling on people here. First one, CE in the small triangle corresponds with what side now in the large one? So I don't want partial sides anymore. Partial sides are only allowed in side splitter. CE corresponds with what side in the big triangle up there? Okay, here we go. Choo-choo. Jayla? CA, perfect. CE over CA equals, go back to the small triangle. CS is another full side, and that corresponds with what full side in the big triangle up there? Taylor? CT. So I could do it that way. But this is not a choice, unfortunately. You have to use side splitter on this one. Okay, this is not a choice. But I just want to let you know you can still use full sides. Questions here before we get to another one? All right, this one here. First, these are parallel. Tells me it's a similar triangle problem. Maybe I could use side splitter, maybe not. Let's see what I was given. 24 for AD, DB 12, DE is 4. Find the length of AC. Even though I was given the parallel lines, I can't use side splitter. Everyone see that? Hey, look. Don't do this on yours. That I would be able to use side splitter on. Okay? You cannot use side splitter if you know the lengths of the parallel lines. I cannot use side splitter, so I got to go full sides. Full sides. Give me a side length in the small triangle, we know. Side length in the small triangle, I know here. Zoe? 12. Okay, match it up with the big one now. You can't go 24. You can't go 24. This isn't side splitter. So the 12 matches up with what side length in the big triangle up there? Going here. Maddie? 36. How did Maddie get 36? Because she can add 24 and 12. You can't go 12 over 24. It's not side splitter. Please see the difference, I hope. And then I'm not even going to ask anybody. 4 over corresponds with side X. And there we go. And when you have X, let me know. I'm going deep. Right hand when you have it, let us know. 12. Good work. Hey, quick check. Make sure I don't fall in the trap. Reread the problem. Find the length of AC. Okay, I called ACX. Okay, I'm good. Just to make sure I don't have to do anything with it. Everyone see the difference? Yes, I can use side splitter versus no, I cannot here. 1 versus 2. All right, next up. EF is parallel to HG. All right, this is nothing to do with side splitter, so let's not even speak of it. But how do you know this is a similar triangles proof? Give me a pair of angles up here that are congruent. I want to make sure we understand why this is similar triangles. Rowan, give me a pair of angles. Okay, I got the vertical angles. And give me another pair because the lines are parallel. I didn't need parallel lines for what Rowan just told us there. Keating got another pair? F and H because they're alternate interior. So does everyone see I have angle here, which makes the triangle similar. So now you guys can put the sides in proportion for me. Got to notice it's a similar triangle because nothing up there tells me it is. All right, give me a side from any of the, I don't care. Give me any side. Any side. Let's start this off. Any side. Maddie, give me any side up there, please. FE, 5, yep. What's the 5 match up within the other triangle then? So I can put it over it here. T, 12. Yep, and then we can figure out that, hey, the 1.4x plus 3 matches up with the 6.1x minus 6.5. I'll give you some time here. Take your time, please, because the decimals here might make some of you anxious. So go ahead, cross multiply, distribute. All I want to know is what x is at the end of this, x only. All right, when you have it, let us all know. And then I'll show you a quick hack in case you were nervous about getting this one right. Keating, what do you have there, boss, when you're ready?
24.
Whoa, easy, boss. 5, yeah, x equals 5. Some of you might be nervous because it's got the decimals. Some of you just might be lazy and don't even want to solve it. Some of you might want to double check yourself because I know we got some studs in here that want to do very, very well. A reminder on your calculator, you have equations, and you could go to equations and just type that thing in and it'll give you x. Okay, you don't even need to cross multiply, distribute. So I don't know how lazy you are gonna be, but you just type and that's all you do. All right, type. I know some of you will go out and solve it because that's who you are, which is great. But some of you just type the darn thing in your calculator and it'll give you what x is. Keating already gave it away here, but notice how x is an answer or 5 is an answer. Yeah, pick me, right? Fall in the trap like usual because whoever makes up the Regents knows you got to solve it. So why not put the answer there? But we're looking for HI. So go back and plug it back in for HI. And go ahead, Keating. Now you can shine. 24. Yep. Alrighty, there you go. All good? So again, you remember you always have equations on your calculator you can solve. Especially like this, multiple choice, we don't need to see any work. We're not looking for work. All right, number 4. Again, we're given parallel lines. Which statement is always true? Okay. If you're choosing number 1, that those two are right angles, you're solely going by the looks of the diagram, aren't you? You have no proof that those are right angles other than they look like them, and that's never a reason in here. All right, no chance. All right, are the two similar? Well, what have we gone over the last few problems here? Corresponding angles are congruent. And then by angle, two triangles are similar. Or if you wanted to, notice how they both have angle A in common as a reflexive angle. All right, so by angle, that's why they're similar. Again, a lot of people I know are going to pick one because it looks like it, but can't do that. All right, moving on. I have been solely talking about angle this morning. There are 2.5 other ways to prove triangles similar. So let's go over we already went over angle. There's 2.5 other ways to do it. Anybody want to shine here? Angle. What's up, Taylor?
I know one of them is like if they're congruent, but also similar.
That's the half method. Yep. Yeah. Congruent triangles are similar. Yep. So if you can get them congruent, they are similar. The other two here, side, angle, side, with the tilde next to it. Those sides have to be in the same ratio. And then if all 3 sides are in the same ratio, they're similar. So those are your 3.5 methods of proving triangles similar. So let's go through each of these 4 together and figure out which one cannot be proven similar. Oh, ready? First one. There's only one of these that could possibly be. Right? It can't be angle, don't have enough information, don't have all 3 sides, and they're not congruent. So the only one it could possibly be is side, angle, side. How do you show if it's side, angle, side? 4 matches up with 12. Is that in the same ratio as the other 2 sides? 3/9. That's what you have to figure out. Are those 2 pairs of sides in the same ratio? If they are, it's side, angle, side. If not, that's our winner for the answer. You can check on your calculator. Is 4/12 the same ratio as 3/9? And you figure out pretty quick. Yes! Yes, it is. So we do not want that. Next one, pretty easy, right? What's the next one showing real quick? Angle. That's angle. Those two are similar. And then I go to number 3, and I'm like, whoa, wait a second. There's not much work to do here because are J and G those 2 angles in between those 2 sides? So it's not even side, angle, side because the angle has to be in between. So I don't even care if these sides are in the same ratio. The angle's not in between. Those can't be similar. And for number 4, here's our half method Taylor just went over a minute ago. Those 2 triangles are congruent by side, angle, side. So they have to be similar. Congruent triangles are similar. And as I walk around, go ahead and try one on your own, number 6. With this given information, are these 2 triangles similar? Well, there could only be one possible method based on what we gave you up there, right? Side, angle, side. So everyone now is just testing, are the sides in the same ratio or not? We don't have enough info for angle, angle, or side, side, side. So we've got to test, are the sides in the same ratio? Were those sides in the same ratio or not? Here we go. Choom. Juliana, what do you think? Were those sides in the same ratio?
Yeah.
Yes, they were. 6/9, same as 14. So this is a yes. By side, angle, side, similarity. There it is. Questions? Side, angle, side. All right. Last thing we got to do today, we got to dilate some lines. All right. Where is it here? Edit. I need my grid. Real quick, kids. Just a reminder. I know you hear the word dilation, so everyone thinks bigger or smaller. I get it. Lines cannot get bigger or smaller. It's impossible because they go on forever. What happens when a line gets dilated is either A, it moves somewhere, or it stays right where it is. Okay, it either moves or it stays right where it is. So a couple notes I need you to have down here when lines are dilated. All right, note number one, dilated lines. Remain parallel. Remain parallel. Which, go back to day one. What stays the same then? What stays the same if two lines remain parallel? Slopes. Same slopes, yep. Same slopes. So if you hear a line is dilated, it is parallel to each, they are parallel to each other. And the second note, we got to be aware of where we're dilating around, all right? Be aware where we're dilating around. Could be origin. If we're told we're dilating around the origin, we had a little hack back in the day. We had a hack. And that hack was we could multiply. Well, if I could spell. Here we go. Try it one more time. Multiply by the scale factor. If it's the origin, we can multiply by the scale factor, which we'll do here in a minute for number 13. And there was one other spot we could dilate around. If it's not the origin, let's see if anybody remembers this bad boy. If the center is on the line already. So we're taking a line, the center of dilation is already on the line. Anybody remember what happened to that line? Nothing. Stays the same line. So let's just make sure we pay attention to, hey, where am I dilating around? All right, now let's hop back to number 13. Here's what we're doing. We're taking this line L, and we're going to dilate it by 2 around the origin. Okay, it's not getting bigger or smaller. All right, but it is going to move. But it is going to remain parallel, which means the slopes are still going to stay the same. So hopefully, whether you've been practicing or not, you can tell me what the slope of this line is after a few adjustments. So I will let you work on that part on your own. You can either figure that out by solving for y, or there is a calculator hack, right? I showed you on day one. You choose what you want to do here. What is the slope of that line first? You can choose to get it into y equals form, or you can choose the calculator hack. Your call. What is the slope of this line? When you have it, let me know. Slope of this line here, Lennon. 3, thank you. Slope's 3, which means my dilated line will have a slope of 3, right? My dilated line will have a slope of 3 because they're parallel. The only thing I need to figure out is what's my new y-intercept? Well, you tell me, what's my old y-intercept? And then I'll help you. What was the old y-intercept? Either looking at the calculator or transforming it on your own. What was my old y-intercept up here? Shoom, let's try that again. There we go. Juliana, my old y-intercept? -4, right? You can either transform it into y equals or look on your calculator. So the old one was -4. Everyone, right? But where did I dilate around? Go back to the problem. Where did I dilate? Where's my center of dilation here? Jayla? Origin. So to find the new y-intercept, I can multiply by whatever the scale factor is in the problem, which is 2. The scale factor is 2. I can only multiply by that if I was dilating around the origin, which I am. So my new y-intercept, -8. Please put the two together and let's answer this darn question now. What's the equation of my new dilated line? Put the two together here for me, Taylor. New equation of this line. Y equals
3x minus 8.
There we go. Everyone see where the 3 came from. They remain parallel. The -8, I can multiply by the scale factor because it was the origin. Good? All right, now we can fly through the rest. Now I got all that info out there. You guys go ahead and do 14. Go ahead and do 14. I'm dilating that line with the scale factor of 3/4 at the origin. At the origin. So 2 of these can get eliminated right away. And probably even 3 of them. And what are we thinking here for your choice when you're ready, Zoe? Choice 4. Slope stays the same. You take your old y-intercept, multiply by the scale factor, and that's where the -3 comes into play because I am around the origin. All right, anything there now? All right, let's roll to 15. I have a triangle ABC. I'm going to dilate that by 3. So before I draw this next one, is it getting bigger or smaller, this triangle? I'm going to dilate it by 3. Are the sides getting bigger or smaller if I'm dilating by 3? 3. Is this going to be a bigger triangle or a smaller one here? What are thoughts, Jackson? Bigger one, yep, by 3 times the size. 3 times the size. All right, which one's true now? Which statement is true? Read everything carefully. If I multiply A prime, B prime, everyone see that side right now, right here, A prime, B prime. If I multiply that side by 3, am I going to get the side length of AB? No, I'm going to get something much bigger. Let's be honest here, right? I get something much bigger. I multiply that by 3. So that's out. All right, next up, what if I take is B prime C prime the result of taking BC and multiplying it by 3? If I take BC, multiply that one by 3, do I get B prime C prime? Going from here to here now, multiplying by 3. Yeah. All right, I'm getting bigger by a scale factor of 3. Why don't the other two work? When you dilate, anybody, what's happening with the angles? Stay the same. They're congruent to each other. They're not 3 times or a third of each other. They're always congruent to each other when you dilate. Good. All right. Okay, now the scale factor is 1/3, and the point is already on the line. All right, what did we talk about a couple minutes? If the center of dilation's on the line, what happens to our line? Look back if we need to here. Zoe, if the center of dilation's on the line, what happens to the line? What's that? It does remain parallel, but if it's nothing happens if the center of dilation's on the line. Nothing happens. It does not move. Nothing happens. So as you look through those 4 choices, which one tells me nothing happens, even though it doesn't say nothing happens? Which one are we looking at for this one? Rayhan? For number 16? Which one is telling me that nothing changes on the line because it's the point's already there? Which one of these choices is telling me that nothing is changing? It's saying the slope's changing.
Oh.
Okay, nothing is changing about this line. The slope, the y-intercept, nothing. Which choice is telling me that? There you go. They remain the same. Okay, everyone see the difference between origin versus point on the line? All right, 17, and I'm going to let you do 18 on your own. All right, again, we got this dilated by 3, so we already know Jackson told us it gets bigger. Got it? Okay, which statement is true? Well, I can cross off 2 of these right away. Because I know they're false. What do we know about the slopes? Stay the same. We've gone over this already, right? Today they stay the same. And I believe Taylor told us, what do you know about the angles? Angles are congruent. They stay the same. They don't get 3 times bigger. So now the question is, does the area get 9 times bigger or the perimeter get 9 times bigger? And here's the answer to it. This actually goes back to our last unit we did. That is a false statement. If you know the side ratios, they are not equal to the ratio of the areas. Anybody remember how we adjusted it? We did what, Taylor? Squared which ones? The area or the sides?
I believe the area.
Oh, we squared the sides. Yeah, we square the sides. If you want to know what ratio the areas are in. So the sides now are in a ratio of 3, right? 3 to 1, you square it. What do we get? If you take 3 and square it, we get 9. Yep. The perimeters would be in a ratio of 3 to 1. The perimeters would be 3 times the others, okay, because they're always equal. But the areas you got to square. If I ask for volume, you cube it instead. All right, see what you can do with number 18 on your own. You're going from ABC onto A prime, B prime, C prime. To try to help you out, what point's not moving anywhere? What point did not move? A, right? So that must be where the center is. All right, because if it was the origin, A would move somewhere else. And is it getting bigger or smaller? As you go from ABC to the prime one, bigger or smaller? Bigger, so it can't be 1/2. All right, 1/2 would make it smaller. So it's got to be choice 4. Okay, you guys see the problems down below. We got plenty of time. If you, again, you want to choose to practice, hey,